Welcome to the Walton Pi. Today we're going to talk about tangents, and I promise I'm not going to go off on many. So a tangent is a curve that brushes right up next to the curve. So that's about the best description we can have without having a formal mathematical definition as well. So each of these little straight red lines, those are going to be tangents to different curves at the point it intersects. So notice how that red line brushes right up next to it, but doesn't cross it except at that one point. There's another tangent for a circle, and here's a tangent for some other curve. Now on this last one, notice how it does intersect the curve in several places, but none of them are right at that neighborhood where it's going to be. That curve is about as good of a tangent as we can get, and so that's going to be what we're going to formalize momentarily. So the definition of a tangent is so the tangent to a differentiable function f of x at a point P is the unique line that passes through P and has the slope f prime of a, where f prime is the derivative of f at a. So the tangent line is the curve that passes through the point and has the exact same slope as the curve at that point. So one way that we can approximate a tangent line is using secant lines, where we slowly move the point closer and closer and closer together, and so as the 2 points approach each other, the line begins to approach the tangent. Notice how, as we are pretty far out, it's not exactly a perfect graph, but as we get closer and closer, it begins to approximate the actual tangent curve. And that's actually how we're going to be calculating the derivative at a point. We are going to use this idea, and we'll talk about this more in the next video. So an example is, let's try and find the tangent line to the curve f of x equals x cubed minus 4x plus 3 when x is equal to 2. So we're going to need two things to figure out what the tangent line is. First, we need to know the point on the line where it passes through, and second, the slope of the line. To figure out the slope of the line, we're going to need to know how to find the derivative of a function at a point, and that's going to be covered in the next video. So to work this out, I'm just going to provide you what the slope of the curve is at x equals 2. Once you know more about the derivative, you can do this on your own. So the point where the tangent line will pass through the curve is going to be x comma f of x, so 2 comma f of 2. If we evaluate what f of 2 is, it's going to just be 3, so it's going to pass through the point to 3. So we now have a point and we have a slope, so we can use point-slope form to find the equation of the line. So it's going to be y minus y1 equals slope times x minus x1, or y minus 3 is equal to 8 times x minus 2, or in other words, y is equal to 8x minus 13. I hope this was helpful. Please check out some of my other videos so that you can be able to continue to learn these different aspects, and please like and subscribe if you haven't already so I can continue to make these sorts of videos. Best of luck and good luck with the rest of your math.